Imagine standing at the foot of a mountain that no one else has climbed. Not because it's physically impossible, but because everyone else was too busy climbing the well-trodden paths. This is the modern landscape of meaningful skill acquisition, where the most valuable abilities remain undiscovered, waiting for those willing to explore uncharted territory. In a world saturated with information and skills, the challenge isn't learning. It's learning what's worth learning. Consider this mathematical framework. The return on learning investment can be expressed as ρ equals V times U times D divided by T times P, where V is value to society on a 1 to 10 scale, U is uniqueness or rarity on a 1 to 10 scale, D is durability of skill in years of relevance, T is time investment in hours, and P is probability of success between 0 and 1. Most people chase skills with high value but low uniqueness, creating competition and diminishing returns. The sweet spot? Skills with moderate to high value, high uniqueness, decent durability, reasonable time investment, and achievable probability. These are the skills that remain untapped because everyone else is focused on the crowded spaces. Here's where it gets interesting. As quantum computing advances, we're facing a paradox. Traditional learning follows linear patterns. Each skill builds logically on the last. But quantum systems exist in superposition, potentially solving problems that would take classical computers millions of years. If we apply quantum-inspired thinking to learning, does this mean we should develop skills in superposition states, maintaining multiple potential expertise paths simultaneously rather than choosing one linear trajectory? And if so, how do we collapse these learning wave functions into tangible expertise when opportunities arise? This isn't just theoretical. It represents a fundamental shift in how we might approach skill development in an increasingly complex world. The framework begins with identifying problems that matter. Look for intersections where your interests meet genuine needs. Ask yourself, would this skill still matter in 10 years? Does it solve a problem others are ignoring? The most valuable skills often live in the grey spaces between established disciplines, where they're overlooked by both specialists and generalists. Second, learn like a scientist. Treat skill acquisition as an experiment. Hypothesize. If I practice X for Y hours using method Z, I'll achieve result A. Measure your progress, iterate your approach, and improve systematically. This transforms learning from a passive activity to an active, data-driven process. Third, build bridges, not silos. Connect your new skill to existing knowledge. The most innovative solutions emerge at the intersection of disciplines. A biologist who learns coding, an artist who studies data visualization, an engineer who understands behavioral psychology. These are the combinations that create breakthrough insights. Fourth, teach to learn. The Feynman method works because teaching reveals gaps in understanding. Share your learning journey and watch your mastery accelerate. When you explain concepts to others, you're forced to clarify your own thinking and identify areas that need deeper exploration. Why does this approach matter? In an era of AI automation, the skills that will matter most are those that require uniquely human judgment, creativity, and ethical reasoning, not just technical execution. By learning what others aren't learning, you're not just building personal value, you're creating the tools we'll need to solve tomorrow's problems. The future belongs not to those who master today's skills, but to those who learn how to learn what's next. As the pace of change accelerates, our ability to adapt and acquire new, valuable skills becomes our most important competitive advantage. The question isn't whether you can learn, it's whether you can learn what will truly matter. Start by looking at the problems that keep you awake at night, the questions that no one seems to be answering, the intersections where your unique perspective could make a difference. Those are the places where meaningful learning begins. And as you develop these skills, don't just collect them. Connect them, apply them, and share them. Because in the end, the most valuable learning isn't just about personal growth. It's about contributing to something larger than ourselves.
Imagine walking through any neighborhood and seeing crooked doors, sagging frames, and weathered thresholds not as problems to be ignored, but as opportunities. Each broken door represents a chance to learn practical skills that save money, build confidence, and strengthen community bonds. In a world where we're increasingly disconnected from tangible problem solving, fixing a door becomes both a practical skill and a statement of self-reliance. Doors are the literal and metaphorical gateways to spaces we care about. When they don't work properly, they don't just create inconvenience. They affect security, energy efficiency, and our sense of safety and belonging. Learning to fix them isn't just about carpentry. It's about understanding how things work, developing troubleshooting skills, and becoming someone who makes things better rather than just consuming them. Before diving into fixes, Let's understand what we're working with. The door itself is typically 1-2 inches thick, either hollow core or solid wood. Hinges, usually 3, connect the door to the frame. The strike plate is a metal plate in the frame that the latch engages with. The lock mechanism includes the cylinder and latch assembly, and the frame is the surrounding structure that supports the door. When a door sticks, it's often because it's swollen or the frame has shifted. First, identify where it's rubbing. Does it stick only in certain weather? Does it rub against the frame at the top, bottom, or middle? For swollen doors, sandy areas making contact. For shifted frames, adjust the strike plate or door stop. For persistent issues, consider planing the door edge. Loose hinges are one of the most common issues and easiest to fix. Can you wiggle the door when it's closed? Are there gaps between the hinge leaves? First, tighten all screws with a screwdriver. If screws strip out, remove them and fill the holes with wooden toothpicks and wood glue. Let dry, then reinsert screws for a tight fit. For severely damaged hinges, replace them entirely. If a door won't stay closed, it usually means the latch isn't engaging properly with the strike plate. Check if the strike plate is tight. If the latch misses the strike plate, mark where it hits and adjust the plate position. If the latch is worn, replace it with a new one. Test the alignment by closing the door slowly. You don't need a full workshop to start. The essential toolkit includes a screwdriver with both Phillips and flathead heads, a hammer, tape measure, sandpaper and medium and fine grit, wood glue, utility knife, level, wood filler, and a basic saw like a hand saw or reciprocating saw. Here's something to ponder the next time you close a door. Why does a door close faster when pushed near the handle rather than close to the hinge? And how does this relate to energy efficiency in our homes? The answer lies in rotational physics. When you push a door, you're applying torque, which is force multiplied by distance from the pivot point. The handle is farthest from the hinges, so applying the same force there creates much more torque than pushing near the hinges. This means less energy is needed to close the door when pushed properly. But here's the forward-thinking part. This same principle applies to everything from automotive design to energy efficiency in buildings. Understanding torque and leverage helps us design more efficient systems that require less energy to operate. In our homes, this means everything from windows to cabinet doors can be designed to operate with minimal effort, reducing our energy consumption over time. Once you've mastered the basics, you can explore more advanced techniques. Adding weather stripping and door sweeps can significantly improve energy efficiency and comfort. A properly sealed door can reduce heating and cooling costs by up to 15%. For aging or disabled individuals, simple modifications like lever handles instead of knobs or adding grab bars can make a huge difference in independence and safety. Beyond basic locks, reinforcing strike plates, adding deadbolts, and improving door frame construction can dramatically increase security. The most valuable aspect of learning to fix doors isn't just the skill itself. It's the confidence that comes from solving problems. Each successful repair builds self-efficacy, making you more likely to tackle other challenges. In a world where we're often encouraged to replace rather than repair, developing these skills creates a sense of empowerment. You're not just fixing a door, you're participating in a culture of sustainability and self-reliance. When you learn to fix doors, you're not just helping yourself, you're becoming a resource for your community. Elderly neighbors, young families, anyone on tight budgets benefit from someone with these practical skills. Imagine if more people in every neighborhood had these basic repair skills. We'd reduce waste, save money collectively, and build stronger connections through mutual help. The broken door becomes an opportunity for connection rather than a source of frustration. Getting started today is simple. Find a door in your home that needs attention. Identify the specific problem. Gather the basic tools. Start with the simplest fix. Document your process and share your learning. Remember, every expert was once a beginner. The door you fix today might be the one that teaches you the most valuable lesson of all, that you have the power to make things better, one small repair at a time.
Imagine being at a restaurant with friends. The bill arrives, and while everyone's fumbling for calculators or doing awkward mental math, you instantly calculate the perfect tip with exact precision. Not just 15 or 20, but any percentage, any amount, with confidence and speed. This isn't party trick magic. It's a practical superpower that saves time, builds mental agility, and makes everyday financial interactions smoother and more dignified. Our brains are wired for mathematical thinking, but most of us never fully develop our innate computational abilities. When you calculate tips mentally, you're not just doing arithmetic. You're strengthening neural pathways that enhance problem solving, memory, and quick decision making. Studies show that regular mental math practice can improve working memory capacity by up to 15 and increase processing speed in daily tasks. Start with the foundation. Fending 10 of any number is simply moving the decimal point one place to the left. 4750 becomes 475. 13240 becomes 1324. This is your anchor point. Once you have 10, You can quickly derive other percentages. 5 is half of 10, 20 is double 10, 15 is 10 plus 5, and 25 is 20 plus 5. For trickier percentages, break them down. 18 equals 10 plus 5 plus 3, where 3 is 1 times 3. 22 is 20 plus 2, and 17 is 10 plus 7, where 7 is 5 plus 2. Start with restaurant bills, then move to other scenarios like sales tax, discounts, or splitting costs. The more you practice, the more automatic these calculations become. As artificial intelligence becomes increasingly integrated into our daily lives, one might ask, if calculators and smartphones can do all the math for us, why bother learning mental calculation? Here's the revolutionary perspective: mental math isn't about replacing technology. It's about developing computational literacy that allows you to verify AI results, understand algorithms, and maintain human judgment in an automated world. When you can instantly spot errors in automated calculations or understand the logic behind AI recommendations, you gain a unique advantage in the digital economy. This computational awareness is becoming as essential as reading and writing in our increasingly data-driven society. Mental tip calculation is just the beginning. These skills translate to quick percentage calculations for shopping discounts, understanding interest rates and financial decisions, estimating costs and budgets on the fly, building confidence with numbers in professional settings, and developing a foundation for more complex mathematical thinking. Week 1, focus on 10 and 20 calculations with random amounts. Week 2, master 15, 25 and basic combinations. Week 3, practice with tax, included totals and split bills. Week 4, challenge yourself with complex scenarios and time limits. When you master mental calculation, you're not just learning a skill. You're developing a mindset of numerical confidence and computational independence. This translates to better financial decisions, improved professional opportunities, and a deeper understanding of the mathematical patterns that govern our world. In an era where many feel numerically anxious, becoming fluent with numbers is an act of empowerment that benefits both individuals and society at large. Remember, every mathematical challenge you solve mentally strengthens your brain's problem-solving networks, making you more adept at tackling life's various complexities with clarity and confidence. Imagine being able to calculate any tip instantly. No phone, no calculator, no awkward fumbling with percentages. What if this simple skill could mean the difference between someone's livelihood and financial struggle? In a world where service industry workers rely on tips for their basic needs, knowing how to calculate fairly isn't just math, it's justice. The service industry employs millions of people worldwide, with many living on tips that make up a significant portion of their income. Yet most people struggle with basic percentage calculations, leading to either unintentionally low tips or the embarrassing need to pull out their phones at the table. Mental tip calculation isn't just about convenience, it's about respecting the people who serve us by ensuring they receive fair compensation for their work. Before we dive into tricks, let's understand what we're working with. 10. Move the decimal point one place left. 15, 10, half of 10. 18, 10, 8 or 10, 10. 2, 20, double 10. These aren't just formulas, they're tools for fairness. When you can calculate 18 instead of rounding down to 15, you're potentially adding dollars to someone's paycheck that directly impacts their ability to pay rent, buy groceries, or afford healthcare. Here's where it gets interesting. Most people don't realize they can use multiplication for percentages. Example är 4, 2, 5, 0, bildat 18 tipp. Instead of 10, 4, 2, 5, 8, 3, 4, 0, total 7, 6, 5. Try 18, 0, 1, 8, equal 4, 2, 5, 0. But multiplication seems harder, right? If you break it down, 0, 1, 8 equal 4, 2, 5, 0, 0, 2, 0 equal 4, 2, 5, 0, 0, 0, 2 equal 4, 2, 5, 0, 8, 5, 0. 0, 8, 5, 7, 6, 5. This mental approach works for any amount and builds your mathematical intuition. In a world where AI is automating everything, which mathematical skill would become more valuable. Complex calculus, or the ability to instantly calculate at 7, 5 of 6, 7, 8, 9 to ensure a human service worker receives fair compensation. This isn't just about numbers. It's about what we choose to value in an increasingly automated society. As algorithms handle more complex tasks, the human ability to make quick, fair judgments in everyday interactions may become our most important mathematical skill. For any bill, move decimal left for 10, cut that number in half for 5, add them together for 15. Exempel 7830 bill 10783 half of that 3 915 round to 3 92 157 83 3 92 1175 for 20 tips. Double the tea amount for 25, add half of the tea amount again. Exempel 5 6 75 21 675 211 35 284 1419. For the new standard tip, take 20 19. For the new standard tip, take 20, subtract 2. Exempel 9340 bill 109 34 21 8 68 18 18 68 1 87 16 81. Start with bills under 50, then work your way up. Practice with real receipts or create sample amounts. The goal isn't perfection, it's progress. Even getting within 50 cents of the exact amount shows respect and consideration. Every correctly calculated tip is a vote for fair labor practices. When more people understand how to calculate tips fairly, it creates cultural change. People stop underestimating service work and start valuing it appropriately. This simple mathematical skill can help shift societal attitudes toward labor and compensation. For complex percentages, break them into manageable parts. Exempel 225 tippon 124 60 224 9225 half of 5 half of 6 23 3 115 total 24 92 3 12 28 04. Round to the nearest dollar for easier calculation, then adjust. Exempel 4 7 8 3 at 18. Round to 48 10 4 80 83 84 total 8 64 subtract the difference 48 47 83 017 så 8 64 017 kär 0 18 i 8 64 003 861. Mental tip calculation is more than a party trick. It's a life skill that promotes fairness and respect. In a world where human connection is increasingly mediated by technology, the ability to perform this simple act of consideration becomes an important social skill. Master these techniques, and you'll not only save time and embarrassment, but also contribute to a culture that values service work appropriately. The next time you're at a restaurant, remember, your quick calculation isn't just math. It's someone's livelihood calculated in seconds. The art of rapid tip calculation mental math that transforms daily life. Picture this: you're at a busy restaurant, the check arrives, and everyone pulls out their phones to calculate the 20 tip. While others fumble with calculators and decimal points, you glance at the total and instantly know the perfect amount to leave. This isn't magic. It's a simple mental math technique that can be mastered in minutes. The ability to calculate tips instantly isn't just convenient. It's a practical life skill that builds confidence, saves time, and makes you more present in social situations. In our increasingly digital world, we've outsourced basic mental calculations to devices. But when you can perform quick mathematical operations in your head, you're not just saving time, you're building cognitive flexibility. The same techniques used for tip calculation can be applied to grocery budgeting, splitting bills, and understanding percentages in everyday contexts like sales and interest rate. Before we dive into rapid tip calculation, let's understand the mathematical principles. 20% tip, simply move the decimal point one place to the left and double the result. 15% tip, move the decimal point one place to the left and add half of that amount. 18% tip, move the decimal point one place to the left, then add 80% of that amount. Here's where the magic happens. For any tip percentage, break it down into 5% increments. First, find 10% by moving the decimal point one place left. Second, divide that result by 2 to get 5%. Third, multiply by the number of 5% increments needed. For example, calculate a 25% tip on $37.80. First, 10% of $37.80 is $4.78. Second, 5% of $37.80 is $2.39. Half of $4.78. Third, 25% equals 5 times 5%, so $2.39 times 5 equals $11.95. Total tip $11.95. Perfect match to the actual calculation. For larger amounts, make the math easier by working with round numbers. For example, 20% tip on $87.33. First, round to $87.50. Second, 10% is $8.75. Third, 20% is $17.50. Double the 10%. Fourth, adjust for the 7 cents difference, which is negligible for practical purposes. Here's as negligible for practical purposes. Here's a fascinating question that connects ancient mathematics to modern cognitive science. If the human brain can process complex mathematical operations in milliseconds when using visual and spatial reasoning patterns, why do most people struggle with percentage calculations, even though they're essentially just fraction manipulations? This reveals something profound about how we learn mathematics. When you visualize numbers as objects or spatial relationships rather than abstract symbols, your brain processes them differently. The tip calculation techniques work because they convert abstract percentages into concrete, visualizable operations that align with how our brains evolved to understand quantity. Neuroscience shows that the parietal lobe processes numerical information, but when we use spatial reasoning like moving decimal points or dividing by 2, we engage additional brain regions, creating more neural pathways and making the calculation feel more intuitive. This is why people who learn these techniques often describe the answers as appearing rather than being calculated. Their brains have found a more efficient processing route. Start with these practice exercises. 15% tip on $32, 20% tip on $64.50, 18% tip on $29.75, 25% tip on $38.99, 22% tip on $71.25. These skills translate to many real-world applications beyond restaurants. When shopping, you can quickly calculate discounts. For budgeting, you understand percentage-based allocations. In investing, you estimate returns and fees. When traveling, you convert currencies and understand foreign tipping customs. Studies in cognitive psychology show that mental math practice improves working memory, attention control, and problem-solving abilities. The rapid tip calculation technique is particularly valuable because it's frequently used, so you'll practice it regularly. It's also socially relevant with immediate practical application, and it's scalable. Easy to start with simple amounts and progress to complex ones. Like any skill, mastery comes with practice. Start with small amounts and gradually increase complexity. The key is to make it a habit. Whenever you see a price or total, automatically calculate what various tip amounts would be. The true value of this skill extends beyond the mathematical operation itself. When you can confidently handle financial calculations in social situations, you reduce social anxiety around money. You become more present in conversations without phone distractions. You demonstrate competence and attention to detail, and you build a foundation for more complex financial literacy. As artificial intelligence handles increasingly complex calculations, the ability to perform basic mental math becomes more valuable, not less. It's a human skill that machines can't replicate. The ability to understand numbers intuitively and apply them in real-time social contexts. In a world where digital devices mediate so many of our interactions, the ability to perform quick calculations in your head is a form of cognitive independence. It's not just about tips. It's about maintaining your mathematical autonomy in an increasingly automated world. Take this technique and use it starting with your next meal out. Keep practicing until the calculations become automatic. You'll be amazed at how quickly this simple skill becomes second nature, and how much more confident and present you feel in social situations. Remember, the goal isn't to replace your calculator, but to build a complementary skill that makes you more capable, confident, and engaged with the world around you.